Pressure measurement and calibration for process instrumentation. Pressure units. Pressure equals force, area. SI units, Newton/square meter equals Pa, Pascal. kg/cm2 is based upon SI units, but Pa is the officially recognizing unit. British units, pound/inch2 equals psi. Many units are based upon the pressure exerted by a column of liquid. In Hg, mHg, in 2O, etc. Converting between units is easily done by multiplying by an appropriate factor. Ideal gas law. Combining Charles and Boyle's law results in the ideal gas law. P equals kT/V. Chemists often use PV equals nRT. K, or nR, is a property of the gas. Example. Volume smaller and or temperature higher will increase pressure. PV equals nRT, P, V, N, R, T, K. Types of pressure measurement. Gauge. Pressure relative to atmospheric pressure. SIG indicates this type of pressure. Differential. Pressure difference. SID indicates this type of pressure. Absolute. Pressure relative to a perfect vacuum. PSIA indicates this type of pressure. Definition of pressures. Every pressure is the difference between two pressures. Pressure that is measured relative to vacuum is absolute. Vacuum. Atmospheric pressure. Definition of pressures. Every pressure is the difference between two pressures. Pressure that is measured relative to atmosphere is positive and negative gauge, relative. Vacuum. Atmospheric pressure. Definition of pressures. Every pressure is the difference between two pressures. The difference between two pressures, neither of which is necessarily vacuum or atmosphere, is differential. Relative. Vacuum. Atmosphere pressure. Pressure measurement. The manometer gauge. Atmospheric pressure. Atmospheric pressure. The manometer gauge. Under static conditions, both sides will be at equal heights. Pascal's law. Gauge pressure. Applied pressure. Atmospheric pressure. Apply pressure to one side of manometer, leave other side vented to atmosphere. H G R equals P rho G H. Differential pressure. High pressure. Low. Apply two pressures to both sides of the manometer. Again. H G R equals dP. Absolute pressure. Pressure relative to a vacuum. Barometers by definition measure absolute pressure. Vacuum. 760 millimeters. Atmospheric pressure. Mercury. Pressure calibration basics. Pressure is the second most commonly measured PV. Pressure controls used in virtually all processing manufacturing industries. Petrochemical, food and beverage, pharmaceutical, etc. Environmental, motor and process pressures. Many different measurement technologies. Strain gauge. Capacitive. Piezoelectric. Deadweight balances. Pressure transmitter. Linear. Converts pressure to linear or square root responding 4 to 20 mA or DC voltage. Millions in service, require service and calibration. Pressure controlled current regulator. Plus. Dash. Sensor input. Gauge. Absolute. Differential. 24V loop supply. Pressure transmitter. 3 to 15 psi. 7. 6. Pressure transmitter, Square root. Converts pressure to square root responding 4 to 20 mA or DC voltage. The square of the input percent of span produces that percent output. With 25% of span applied, 50% output. Plus. Dash. Sensor input. Gauge. Absolute. Differential. 24V loop supply. Pressure transmitter. 0 to 120. 7. 6. Analog pressure transmitters. Fixed ranged. Some turn down and rearranging via jumper settings. Adjustment manual, 0, 4 mA, and span, 20 mA. Some include linearity and dampening adjustment. Signal conditioner technology, little or no digitization. Analog transmitter. 0. Span. Analog electronics. Input sensor. 4 to 20 mA output. Fluke 740B series documenting process calibrators. Pressure transmitter calibration using a portable calibrator, connection. 49. Configure the calibrator. Fluke 740B series documenting process calibrators. Configure the calibrator. Set the correct source and measure functions. The measure portion of the screen should be in mA. The source portion of the screen should be in pressure. Define the span parameters, acceptable tolerances and test strategy, example, 0 to 50 to 100%, for the test. 49. Documenting the as-found test. For each test step, capture the applied pressure. Measure the actual mA value. Calculate and document the error percent of span for the measured mA. Record the tag, serial number and operator for the as-found result. Adjusting to within tolerance, as left test. If the as-found test passes within limits, no adjustment required. Return transmitter to service. If the as-found test fails, adjust the 0 and span. Run the as-left test, confirm, document adjustments. I2P transmitters. I2P converts a 4 to 20 mA signal to a 3 to 15 psi signal. Often used with control valves. Used as a bridge between 4 to 20 mA loop and 3 to 15 psi pneumatic technology. Typically operate from a 20 psi or greater pressure supply. A current-controlled pressure regulator. Pressure output. 4 to 20 mA current input. Supply. Pressure. Tilde 20 psi. I2P calibration using a portable calibrator, connection. Configure the calibrator for the test. Select measure pressure and source mA. Define the test parameters. Document the results. Adjust an as-left test. Apply the 0% pressure value and adjust the 0. Apply the 100% pressure value and adjust the span. Verify 50% linearity. Run the as-left test. Document the results. Smart transmitter calibration. Smart pressure transmitters have no physical 0 and span adjustment. Smart transmitter. PBURL. PBLRL. Sensor trim. Pressure 0. Loop test. Output trim. Input. Sensor. Sensor. Input. Range computation. Instrument output. 4 to 20 mA. Output. PV. VOW. Smart pressure transmitter. 3 stages. Sensor block. Converts pressure signal to digital, AD. Range computation. Holds the program settings for 0, LRV, and span, URV. Outputs VOW digital output signal. Output section. Receives the VOW command and output a mA signal, DA. Input and output section are individually calibrated to provide overall performance. Sensor. Input. Range. Computation. Instrument. Output. 4 to 20 milliamperes. PV. VOW. Sensor trim. PVURV. PVLRV. Loop test. Output trim. A HART instrument is more complex, having 3 distinct stages. Example: smart calibration. Almost identical to analog transmitter connections. HART cable connection required for digital adjustment. Rosemount 275 or 375 can be used in place of fluke 744 for digital adjustment, requires an analog calibrator. Configure the calibrator. Acquire the test parameters, HART query. Configure the input/output of the calibrator. Define the test parameters. Configure the measure and source function of the calibrator. Define the performance test. Acquire HART configuration. Calibration, as found test. Document the pre-adjustment transmitter condition. Calibration, digital adjustment. Perform HART trim on the transmitter. As left test verify post-adjustment condition of transmitter. If still out of tolerance, OT. Repeat adjustment. Rerun as left until it passes within tolerance. If it cannot be satisfactorily adjusted. Was the test tolerance too tight? Were there leaks in the fittings? Repair or replacement if necessary.